Once you've learned to solve a few missing line problems, the next step in the visualization process is to work on some problems where there is a missing view. You'll notice that we have a front view of this object, we have a side view of the object, but we're missing the top view. And so now, instead of just solving for a few missing lines, we have got to be able to figure out what the entire missing top view looks like. Now, one thing that's important is that we keep our drawing centered on our drawing sheet. And you'll notice that the distance from side to side here is the same. And so we want to keep the distance top to bottom from the border the same. So I'm going to set my dividers to whatever this distance is, and then I'm going to go up to the top and put a mark, and I'll put a construction line there, and that's where we will start with our top view. I'll put a construction line across, and so my top of my top view is going to be right here, so that I've got the same amount of space here that I do here. The sides should be equal, the top and bottom should be equal. The side and the top don't have to be equal, however. Okay? Alright, now the next thing we want to do is we want to project a vertical line from the far right side of our side view. Okay, so we've added a construction line on the far right side of the side view, and that creates an intersection. At this intersection, we are going to draw a 45-degree miter line. This 45-degree miter line is going to allow us the ability to project the depth dimensions off of the side view up to the miter line and then transfer them across into the top view. That's how we will get our depth, this distance in the top view. We'll get our width by transferring from the front view. So the two dimensions that will be in the top view will be width and depth as it's transferred up there. Okay, so just like we did with our missing line problems, now we are going to project all of our lines from the side view up to our miter line using a vertical line. So we'll just use the edge of our triangle and we'll begin projecting all of these lines that we intersect with as we slide across, including the center line. We'll take that, both edges of this slot, and the other edge of our top piece. And then finally the far edge of our side view. Okay, so you can see we projected all of the features that we found as we slid across with our triangle. We projected all of those up into the miter line. Okay? Now, we will go to the front view and we'll just continue. So, we'll take the front edge of the front view, project that up, and each time we bump into a new feature, we'll project that line. Oh, better have the start of the angle down here. Got to project that. Top of the angle, better project that. Other side of the angle, better project that. And finally, we'll take the far end of our object. Okay, so we've projected all of the features that we found in the front view. We've projected those up. Okay, once we've done that, now we can take our horizontal slider and begin to transfer across all of the lines that intersect with the miter line. And I'll try to do this without getting my head in the picture here. Okay, there's that one. Ran out of lead. Okay, go up to the next one. Project that across. Go to the next one. Project that across. Go to the next one. Project that across. We just keep working our way up the line, along the miter line here, projecting each of the features that we've have found on the miter line. Okay, now that just looks like a big maze now, doesn't it? And so we have to begin to compare which features go with which features. Okay, let's start here. Does this line run all the way across? Yes, it does. It runs the entire depth of the object, so that line will stay just like it is. Okay, let's go to the next feature. How about this one? Yes, it's the same length. It's right behind that, so that one is going to stay. Okay, top of the notch, that's this hidden line. That goes the full width, so that one stays. This one is the bottom, but it goes all the way across, so it stays just like it is. Okay? Same with this one. Okay, now, you notice that there is part of this object that's not quite as wide, right here. Okay, so if we follow those two lines up, we go up to this line, and we come across until we find the face of that feature. From there out, there aren't any of these other lines. Okay? And so we will begin to start erasing those. Just keeping the very outside edge lines. Okay? So we've taken out a few lines, haven't we? Okay? Now, the same is true with the inside pocket here, and so we erased those as well, because it starts right here and only runs to here. It runs between here and there. Okay? Now, notice we've got a slope here. And that slope starts here and ends there. Starts here and ends there. Okay, so what we've got to do is we've got to figure out how that slope looks in the top view. Well, the bottom of the slope starts out here on the very far outside, and this point and this point intersect right there. See that? That comes up and over. This one comes up and meets it. So there's one point of intersection. Okay, now let's look at the top of that slope. Starts here. That one comes up and over. So along this line, it comes until it meets this line coming up right here. There's our second point. Okay, now let's look at the other side. This one goes all the way up, comes across and meets that one right there. This point comes up, follows along this line until it meets this one coming up right here. Okay, what happens is those points are connected by a line. And so in the top view, they're going to be connected by a line on both sets of points. Okay, so the front of our object, on the side view, it looks like this. The slope surface is in the front view. We can see the slope in the side view, and because of the way it's angled, we can also see it in the top view. And look at that, it's the same shape. It's just been rotated 90 degrees. But there's that same shape that we have right here. Now, we have a slope here and here. And the shape of that slope is this thing right here. Well, if we go up and look in the top view, which is opposite these two angles, we'll once again see that same slope. See, here it is. There's that same shape right in that area. Okay? Now we have some hidden lines that are going to be going underneath it, but look, on both sides there is that shape. So there's a principle here. When you have a slope surface, no matter what view it's in, you will see the surface and it will be the same shape in the two views that are opposite the slope. So if it's this slope, we're looking at this surface and that surface. If it's this slope, we're looking at the surface that looks just like this, but it's on the back side, and we see it up here as well. If we're looking at this slope, we see it here and here. So there's a way to double check yourself and make sure that you've got everything. Now, give me just a minute and I'll darken these lines. Alright, here's the finished product. If you look carefully, you'll see hidden line for bottom of notch, hidden line for bottom of notch, hidden line for bottom of notch. Object line, which is this face, and object line for the very back. Looking at everything that was projected from the side, we've got object line here, which represents this edge. We've got hidden line here, which represents this inside edge of the hole. We've got center line. We've got hidden line. We've got object line. And of course, in this area, we've got this slope surface. In this area, we've got that slope surface, and they look like this. In this area, we've got this slope surface. So there you are. That's how you solve a missing view problem. Remember, when you do this, that you can use a miter line to transfer from the side view to the top view. Well, what if you were given a top view and no side view? You could do the same thing, just put in a miter line and transfer over and down. How did we locate the miter line? We took the far right edge of the side view, projected a construction line from that, and we looked at the distance that we had from the border to the edge of the part, and we transferred that distance to the top so that this space would be equal. And we projected a line across from there. Where they met, that's where we put our 45-degree miter line. And then we just begin transferring to solve the problem.